thanks. Thanks for everyone for coming. We're going to talk about the engineering of our data for the data economy. And what I thought I would do to kind of kick things off is get a little bit of inspiration around where have we been? What have we seen? What's inspired us? What's been really interesting? And maybe start with you. Go ahead.
Okay, thanks, Michelle. So to give a little bit of context, Kafka was born at LinkedIn 5 years ago when we thought, well, the only way things were running were sort of in a once-a-day batch fashion in our warehouse. And we saw really two trends coming, which is that data has grown in velocity, variety, volume, and it needs to be processed in real time because that's how users use our website. And we essentially saw that there weren't really many good choices. There were on one side like messaging systems that process data in real time, but in very small sizes. And on the other side, warehouse, which process data in batch. And essentially, we created Kafka to solve that problem, which is, collect data in large varieties and volumes and make it available in real time. So 5 years down the line, it's now used in thousands of companies from LinkedIn, Netflix, and Ubers to Microsoft and Goldman Sachs and Cisco. Confluent is a company behind Kafka, and that is what we're doing right now.
Thanks. Arun?
Thanks, Michelle. Good afternoon, everyone. Hopefully, we'll keep you awake for the next 30 minutes as you digest your. All right. Barry?
Go ahead.
My involvement with this whole data business started, about 10 years or so ago. We were all at Yahoo, and we were trying to come up with a new system to sort of store and process data better at scale. And then the only use case we had in mind then was web search. I sort of still think of web search as the quintessential big data problem. Our brief back then was to build a system which would allow us to store and process, multiple copies of the web. Sort of build a time machine for the web, if you will. I wouldn't say it was the most noble of pursuits. We're trying to get people to click more ads. But then, as we've taken Hadoop from those sort of beginnings at scale, if you will, but to more general sort of use cases, one of the things that definitely inspires me and kind of gets me out of bed in the morning is some of the work we do in healthcare. We recently announced a partnership at Hortonworks with the Arizona State University, where we're doing a bunch of work on cancer research. It allows us to take a look at how individual variations in genomes affect and influence the cancer bearing cells there. So it's certainly a big data problem. As you can imagine, we're talking about tens of thousands of genes, and each of the sequences here are millions of bits of data. Certainly a big data problem, 20 to 20 plus billion rows of data. But the fact that researchers used to struggle to do this with SQL in the past, now with technologies like Hadoop and Spark and so on, it allows us to be much more effective and try and hopefully make a difference.
Yeah, so Spark, it's a processing engine which processes data at scale. And we started it in 2009 at Berkeley. And the reason we started it is because we hit some use cases which are not well addressed by the technology back then. In particular, machine learning, iterative computation, you do many iterations until you converge, and interactive query processing. So that's, we started, supporting these use cases back then, and soon Spark became more general processing engine supporting other kind of workloads, including, of course, batch, but also graph processing and, even streaming. Today, Spark, it's widely used by thousands of companies. It's very popular, and in 2013, we started Databricks, which is a company behind Spark, which provide a hosted platform based on Spark to make big data simple.
Great. So maybe picking up on that, we're talking about Spark, certainly from a Hadoop perspective, we're looking at Kafka. Why are these, oops. No problem, sure. So we're looking at Spark, we're looking at Kafka, we hear it everywhere. It seems like it's the next best, the next biggest thing. Why are people so excited about it? What are we going to be able to do now that we couldn't do before? Go on.
I can go first. I think, from my experience, what I see with Kafka and Confluent, companies are making a big shift towards real-time, low-latency processing. Earlier, the old world was your data warehouse collects all this data once a day at midnight, and next day you're ready to see the results. That is too late to know some problems. So, for example, big box retailers, what they're doing with Kafka is they're collecting data about orders and shipments and reacting to it in real time in order to do dynamic pricing. And that is essentially a big competitive advantage that, for example, Amazon has. At the same time, most of the businesses that they do is on a couple of days, like Black Friday. So it's just too late to know any problem that occurs the next day. I think Kafka and Spark, or for that matter, any kind of real-time data and processing is really changing the rate at which you react to important events that are important to your business to essentially, basically provide a much more intimate customer experience.
I can go next, thanks. I think, so as we've been in the market now for 5+ years, and we see this, see how people use a lot of the technologies we bring, whether it's Kafka, Hadoop, and Spark. It's important to sort of keep the big picture in mind, right? The big picture is we see sort of three large trends. One is you're certainly seeing a world where more data is getting generated than ever before. I don't think anybody debates it at this point. So there's lots more data. Equally importantly, it's getting cheaper to move data around. In last year, I spent a lot of time with a bunch of customers in the oil and gas industry. They've, even as recently as the last 2 or 3 years ago, they've realized that their biggest sort of operational cost was actually moving data from their oil well or whatever it is to their data center. And the reason was because they had to use something like satellite communication channels to actually move data. Now with 3G and 4G being so prevalent, that's certainly no longer the case. So they literally had to rethink their business. They went from moving about 7 bits of data every 30 seconds to 200 bits of data every 10 milliseconds, right, or 100 milliseconds. So that's a sea change in their business. And in their business, for example, if you can predict the failure of one drilling bit or drilling machine, it saves them hundreds of, literally millions of dollars, because their biggest cost is they no longer have to go order a new machine after it breaks, right? If you can do it 3 months before, then even as this machine breaks down, they can actually have the next one in effect. So just one example. So you have certainly lots of data, you have cheaper channels, and again, the last bit of it, or the third leg of the stool, is the fact that technologies like Hadoop and Kafka, you can actually now store this data at scale compared to what you were doing in the past, right, in terms of economics. So the combination of these three, and last not least is, it's getting cheaper and cheaper to actually produce custom hardware. You can make your own ASICs and do lots more processing on the edge, if you will. The combination of these is sort of what is driving the sea change in the industry.
Yeah, so first let me make a point. So we are here representatives from Kafka, Hadoop, Spark. So all these technologies work together, and there are many deployments in which they are, Spark uses Kafka, Spark is running on top of Hadoop, and so forth. So with this being said, I like also to take a step back, and if you think about now, almost every company collects data, right? Raise your hand if your company has a big data project. Okay. So, and why do you collect this data? Because you want to extract some value. You want to, improve your business processes. You want to improve your products, services. You heard just, some examples. However, today, getting from this data, which is unstructured, is noisy, and so forth, and you have a lot of sources of data, to get that value, to extract that value, it's extremely hard. So the main goal, one of the primary goal of Spark and by extension Databricks is to make this process of extracting value out of the data much simpler. And this is complex for a variety of reasons, but also because the pipeline to get from the data to the value, it's complex. You need to get the data. You need to clean the data. You need to explore the data. You need to get some deep insights after that, do machine learning. And then you need to build data products, right? It's ad targeting or, personalized recommendations. So it's very complex. And one way Spark is making this easy, because it's, like I mentioned, it's a unified engine. So many of these workloads or many of these tasks you can execute on top of the same platform. Okay? So you need to learn, one API. You need to manage one system, and it's much easier. And this not only that, what does it mean easy, is also it reduces the time from data to get that value, right? And Databricks go one step forward, because it's also making the creation of the clusters, management, and it has a set of very easy to use tools on top of Spark to allow you to interactive exploration, visualization, and so forth. So that's basically the theme, and I do think that we are still at the beginning of addressing that challenge, making big data simple.
Yeah. So really kind of what we're hearing here is, before, when we were overwhelmed with all of the information, it was nice to be able to just have a place to go to get into it, to play around. You get an insight here, you get an insight there, and even if it's in real time or even almost real time, the insights are coming faster, and we're able to get more insight faster, which means we can take better actions, make better decisions. Mm-hmm. Mm-hmm. Yeah, it's really speeding up our businesses. Yeah. So,
yeah.
Yep. Did you want to add to that?
Yeah, definitely. I think I was saying, you want to extract value from the data. In many cases, what is its value? It's making some decision, some informed decision. And if you think about the decisions, faster decisions are better than slow decisions. Decisions on fresh data are better than decisions on stale data. Mm-hmm. So, yep. Just to your point.
So I have a question for the panel, but maybe also for the audience as well. One of the things that we've thought about from a big data perspective, and even in the examples that have been provided, there's sort of this automation of insights that happens, and it's automatically powering up processes, creating a recommendation, determining what the next best action is, and it comes out of the hands of the analyst, out of the hands of the business person. So a heavy automation process. But I'm also curious, how many of you are thinking about applying big data from an automated perspective, but are you also looking at it from a decision perspective? How are you providing insights that are helping to make decisions? How are you augmenting the intelligence of the people within your organization to make their lives better, make them more intelligent? So, is anybody moving to that side too? So maybe a show of hands here. Is it focused on automation right now, primarily? Yes? And show of hands in terms of, taking the next step and also providing the insights to the rest of the organization and democratizing, supporting decisions. Yeah. So kind of a balance here. Maybe that goes into, another question that I had. Something that we've seen at Forrester quite a bit as we've been tracking the evolution of big data. There's been a little bit of a frustration around the investments that have been made. So the satisfaction, particularly around insights, has dropped a little bit at the same time that dissatisfaction is on the rise. One of the things that really has been, a challenge has been this idea of access. And if we think about big data and the examples that were provided up here, it's really, providing that access, giving the VIP card to the rest of the organization. And I'm curious, what's evolving within big data that is helping to democratize these insights more, not just from an automated process, but even from, supporting strategic decision making?
You want to go first?
Yeah, so, that's an excellent question. Also, this is one of the focuses at Databricks, actually, is providing a platform which makes easy exactly to do this democratized information. So what does it mean, actually? It means that the work of the data scientists, the artifacts they are building, whether they are reports or some kind of simple analysis notebooks, they can be made available to the other part of the organizations, right? So that's what it is, so they can use it, right? It's like someone builds, a macro in Excel, you are going to use it. That's the same thing kind of, democratization you want to achieve. And this is, again, is going to the easy of use, right? Because things are easy to use, there will be a lot of more people, they can use the tools to look and to explore the data. And we see that, in many of these cases, for our customers, the number of people having access to the data, using that data, increase several times, up to 6 times in some cases.
All right.
Thanks, John. I think from our perspective, given sort of the seat in the house we have when it comes to 800 plus customers using data to make decisions and validate it, one of the things constantly we hear, especially when we've gone from sort of the valley environment to the Main Street, if you will, has been a lot of the focus on governance of data and the security around it. One of the key things that people are looking for is a way for them to discover what data sets they have, understand what governance policy they want to put around it, and sort of tie that in with security. Like if you go into any standard any data warehouse you'll find in an enterprise today, you're literally talking about tens of thousands of tables, maybe hundreds of thousands of columns. Now you need to understand which of these represent sensitive information, because a lot of it is a liability on your balance sheet, right? And how to make sure that you capture the security aspects around it. So one of the things that I'm really glad to see sort of the overall Hadoop community take on is this project we call as Atlas, which allows you to do this metadata management. And equally importantly, marry that up with security so that you now no longer have to go to every column and every row and tag it. You want to do it at point of ingestion with something like Kafka and say, as I'm ingesting this, I want to set up a data pipeline which says this, out of these things, I'm getting this data set, the first bit of data, the first process data set I'm getting from the stream has 3 columns, out of which the third one is sensitive. Now, regardless of what tool you use, whether it's Hive or Spark or any of these things, we're making sure that those tags get automatically flow through all the way. And then you can go set a policy on the tag without having to set the policy on the individual table or the row or the column, right? So I think this notion of governance and security sort of married together is one of the key things that's really, really essential for the big data space.
Yeah, I would definitely second what Arun said here. I think what he's getting at is basically, for a long time, metadata management was sort of an afterthought. Like I saw this at LinkedIn, where the old pipelines were basically allow developers to send garbage in, and then there's one team called the ETL team that untangles all that garbage, cleans all that data up. But if you want to move to a faster sort of getting value from your data, one of the big things in addition to getting the data in is also basically making sure that the data is clean at the point of ingestion.
Absolutely.
And that is something that, at least we got it right at LinkedIn in a big way, which is making sure that we use some of these tools that were not available back then, but using Avro, for example, to make sure that data is clean at the very beginning, where you're not even allowed to send, garbage data in. I think it's a pretty big cultural change in companies where you almost have to train your developers through the tools that are available to them, which is, you make it possible to automatically send clean data in. I think that's a big part of, or more like I see the practical part of making sure that all this big data tooling actually works and is valuable.
Great. I'm going to pass it on over to you. You have a question? Ooh. It's a little, no, can you turn the mic on?
Yeah.
So garbage in, garbage out is a typical computer science problem we deal with all the time. That's not an issue at all at this point. I think the bigger challenge I would ask you is, as you have been evolving these technologies over the last 4, 5, 6 years, right? What are the bottlenecks you yourself see in the fundamental technical challenges that you're seeing, right? One is the standard implementation issues. You go from the Silicon Valley to Main Street, fair enough, scale and real life problems. I understand those, but are there technical barriers that you're facing that you'd say, if I had a magic wand, I could fix these 3 or 4 things? What would they be?
Yeah, do you want to start with that?
Yeah, I could start with that. I think one of the big ones is, we have Spark and Hadoop and Kafka here. I think each one of these are fantastic technologies on their own. One of the, I think, technical challenges I believe that as a user people might face is just how all of these things work together. This is obviously like in a big way, each one of these technologies and the companies behind them are working on integrating, but the interfaces on how you put these three things together are possibly one of the still, I would believe, open challenges that are probably not solved yet. But on the other hand, one big area that all three technologies are focusing on is basically security and making sure that all the policies around expressing your security and privacy policies are available. And I believe that on the brighter side is making a big headway. Both Kafka introduced security policies, Hadoop is 2 steps further where they're building metadata management and tooling around it. And I think that there are possibly multiple categories in which things are good and things are yet to be fixed.
Yeah, I would second that. I think certainly from my own experience as somebody involved in the development of Hadoop, we sort of added security probably 3 or 4 years into its lifetime. Having said that, it's always easy to sort of beat yourself up. Who knows, right? If we'd spent the first 3 years just building security, maybe we wouldn't have had Hadoop, and nobody would be using it, right? It's a hard question to answer. But I would say metadata management is a big thing in the context of the overall data stack. We talked a little bit about it. The second thing I would add is, again to what Neha said, we have a lot of technologies and we continue to add more because the nature of the open source communities are they will find a niche or a problem to solve and they'll go build a solution for it. And it comes back to us as a sort of a vendor to put them all together. Clearly, it's getting harder because the permutations are getting longer. Now, every time we bring a technology in, we got to make sure it works with Kafka and Spark and X and Y and Z, right? Overall, sort of the big picture for me, it's sort of what we work overall in the Hadoop community too is, as we build all these technologies, right now, our customers, whether it's at a bank or an oil and gas firm, they're taking technologies like Kafka and Storm and Spark and putting them together. I think we want to evolve to a world where sort of you'll be able to download a pre-built solution, and that solution is a customer churn or a ingestion app or whatever, right? So we want to be able to get to a world, and in the Hadoop community we call it this notion of an assembly, where you should be able to download a pre-configured set of these pre-configured set of technologies to run a solution or get a blueprint for a solution that's running. In our own example, we recently there's a project in the ASF called Metron, which allows you to do cybersecurity analytics. Now, if you look under the hood of Metron, what it uses Kafka for ingestion, Spark streaming for processing, and so on and so on. As you can see, these are all different set of technologies, which are pre-built, which are put together for a specific use, to solve a specific use case of packet capture and analytics and DOS attacks, reporting and DOS attacks and so on. We want to get to a world where, as a customer, you can download that whole thing and just run it if you have a Hadoop cluster, right? And take away the complexity of having to wire them together, do security, and so on. So I think if we solve that, which is sort of, thankfully on the roadmap for the Hadoop community, we solve that, I think will definitely help with the skills and shortage of skills and the complexity of the platform and so on.
Yeah, so I totally second with the metadata and security are huge challenges today. And in addition to that, I like to point out 2 other challenges going forward, moving 5 years from now or even is that. So one of the big problem even today is like if you it was mentioned Michelle, that it's it's a little bit it was a hype, and now people are a little bit disappointed. So we look quite a bit and we talk with our customers. A lot of times it's not only because the tools maybe are hard to use, it's hard to integrate, like Arun said, but really the data. The data, if you think about where the big data comes, big data comes from logs, pictures, images. It's kind of unstructured data, it's not clean. And then you want to merge this with a lot of other data to, and this is hard. It's hard. A lot of logs are not, that don't provide you what they should provide you. You know, we talk with this, one of these, we had one, you know, fitness customer, like fitness bands. Some of these fitness band company, you know, for instance, when the battery is going low, then it sends garbage, right? So you need to understand, and you need to you know, that will screw you all your, you know, your pipeline. And that's a very hard problem. And so any tools there, and we can develop to make it easy, this will be hugely valuable. The other thing is that going along, this is a longer term. If you are thinking about that you want to make automated decision and things like that, well, you know, then you have an issue there because you want this decision to be robust. And now when you use machine learning is fundamentally a statistics technique, right? So how do you make sure you don't have a lot, you know, false positive or false negatives? How do you make sure that whatever you train is still going to behave well you have noisy input, or when that training system never seen that particular input? So I think that these are the problems we would need to address and solve going forward, you know, to really build very valuable application on top of big data.
So you brought up sort of two themes that have been coming up quite a bit. You know, we're hearing about IoT and what happens with things like fitness bands, where, you know, certainly there's a lot of sensors and monitoring that happens from a medical or an oil and gas perspective. And then there's the machine learning, the hype around machine learning, the hype around artificial intelligence. Is it going to solve it? You know, are we really moving down the right path? What do you see the future is to really understand the meaning of our data, handle these quality issues, do that at scale, as well as marry that up with the security and the access issues?
I can.
Yeah, go ahead.
Sorry, good. So definitely, I think especially one of the things that's interesting for me as someone who's been part of this sort of movement for a while now is that if you go on, if you really look at the whole IoT sort of scenario, what's interesting is there's more data going forward with the IoT space. There's going to be more data generated outside the data center than within your sort of enterprise data center, right? Now, at first glance, that seems like, oh yeah, it's part of the, you know, evolution, if you will. But it certainly brings into sharper focus many newer things, especially when it comes to security. You're talking about data which is moving across many public networks. In a lot of cases, it's also moving across many geographical and legal jurisdictions. There's also this notion of once you have this data generated in all these sensors, you want bidirectional flow control, which means you should be able to modify that data, either for debugging or whatever, at runtime without having to go install another bit of software, because you can't go, you know, and change the bit of software that you have, right? So those are the things why, you know, we've been excited about technologies like NiFi, which came out of the, you know, U.S. government. We see that as really key in sort of security and sort of bidirectional control as being really important in the IoT space.
Yeah, I'll take only the question on the machine learning. So look, machine learning is that, you know, there are incredible advancement over the past few years, even the past year, right? You know, now you have machine learning programs which can beat the world champion at Go, right? You see, you know, like this incredible, you know, translation algorithms. You know, the image recognition and so forth. So it's clear a huge advancement. But it's again, when you go forward, there will be also huge challenges. And I think that a lot of these challenges, not only about, you know, building more sophisticated machine learning algorithms, it's also making them robust. And by robust, I mean robust against the, you know, noisy inputs and unforeseen inputs.
It almost seems like they also have to be able to harmonize the variety of the data and the meaning and the insights out of that as well.
The other thing you mentioned was, looking years ahead. One is, of course, machine learning and AI, which I think most of the VCs are really interested in today. The other, yeah, exactly. As long as you combine it with bots. But the other you mentioned is IoT, and that is also up on its hype curve. I don't know. I think IoT means many different things that are yet a little bit unclear. But to what Arun was mentioning, a big part of it, from what I've observed, is the characteristic of that data is really different. It is streaming by nature. There is a shelf life of value for that data, which means that applications need the ability to both collect and process it in real time, quickly, in order to get most of the value of it, right? For example, you have sensors, and those sensors are pushing a lot of data in high volume, but also really high velocity. And it's probably reporting metrics that you want to respond to quickly. So all our tooling that is, sort of old, where we have tooling around like batch processing of data, unfortunately, for all the problems that it solves, for this particular problem, is probably going to fall a little bit short. That's where we see a lot of Kafka being used, which is like, they want to use Kafka to basically collect all that data, and hopefully they will figure out what to do next with it.
All right, well, it looks like that's all the time. So, do we have time for one question?
Really short.
Okay, really short.
Yes or no question.
Okay. Go ahead.
Ian, this is Vince. I'm actually a mentor at Berkeley Bootcamp. The question is, what is your ultimate dream? Each of you, with this data, and this power, and this knowledge, and this influence we have today, what is your one ultimate dream in life you want to accomplish in your lifetime or possibly
World peace.
Yeah, sure.
Go ahead.
So the question is, what's the ultimate dream?
The ultimate dream.
Arun, it's your dream. We have only like a few seconds.
I worry I'm going to say something very small here.
No takers? Come on, the risk takers up on the stage can't answer the question.
We only need 56 KB of data.
Okay. Maybe that's a dinner conversation. Yes. All right. Well, thanks to our panelists.
Thanks so much.
Thanks to coming.
Thank you.